Um,
Okay, so problem three, we had a voltage across a capacitor. Problem four, we have the current through a capacitor, and we have the initial voltage on the capacitor at t equals -4 with 0. Determine and plot v of t. So this time we're given the current and we have to find the voltage. So if last time we were looking at a derivative, this time what do you think we're looking at? An integral. So for a capacitor, we have that voltage across a capacitor is the voltage at time t equals 0 plus 1 over the integral from t0 to t of I of t dt. Okay, so the voltage on the capacitor at time t was -4. So from 0 to negative, from negative infinity to -4. V of t equals 0. Equals 0. Plus 1 over c times the integral of 0. So it's just 0. So that's okay. From -4 to -2. Let's get the equation of this line. So the equation of that line, I of t, it's a line, so it has a slope. The slope is, we already know the slope because that was the derivative. It's rise over run. And so that's 100 over 2, which is 50. So it's 50t, but if you remember, the equation of line is mx plus b, so b would be the y-intercept. Well, what would be the y-intercept of this line? No, it's where it crosses the y-axis. Where is it going to cross the y-axis? 200. So, V of t will equal the voltage at the starting point, which was 0, plus 1 over 0.2 millifarads is 0.0002 farads times the integral from -4 to t of 50t plus 200. So why am I not doing from -4 to 2? Because I'm not trying to get the voltage at -2. I'm trying to get a function for the voltage over this interval. So I'm taking the integral from -4 to t in order to get the function. Yes. So I found the equation of this line. So I found the equation of the line. Yes. So 1 over 0.002 is what is 1 over 0.002? Can someone do this for me? Just so I don't have. Thank you. 5,000. 0.0002. 5,000. And then my integral is going to be 25 t squared plus 200 t from -4 to t. So that would be 5,000 times, if I plug 4 in, I get, or if I plug -4 in, I get negative 400,
I think.
negative
Negative
400
400
plus, and then when I plug minus, when I plug t in, I get 25 t squared plus 200 t. So this is 5,000 times negative 400 minus 25 t squared minus 200 t. And you can multiply that through if you want. Well, we're going to need to figure out what the voltage is at t equals negative 2 in order to do the middle part. So this is from negative 2 less than or equal to t less than or equal, negative 4 less than or equal to t less than or equal to negative 2. I need to find out what it is at negative 2 because I need that to do the next part. So I need to plug in negative 2. And that looks like it is negative 500,000? $50,000. No, 500,000.
Why would there not also be a negative 8,000? Wouldn't you also evaluate the 200T at negative 4?
I was evaluating it at negative 2. And so I got 400.
Oh, I thought it was, sorry.
Yeah, I was evaluating it at
negative 2.
I thought we were doing negative 4T.
Okay, so that was the integral. I plugged in 4 for the integral. So this is the next part because the next part is from negative 2 to positive 2. The function v of t equals v at negative 2 plus v at negative. So it's this one right here. And so to get what it's going to be from negative 2, I need to know what it is at negative 2. So I'm not evaluating the integral anymore. I'm plugging into the function that I had before in order to get this value right here. So what we have so far is from negative 4 to infinity, it's 0. From negative 4 to negative 2, it's 5,000 times negative 400 minus 25 t squared minus 200 t. And now we're doing from negative 2 to positive 2. And that's the part we're doing right now. So and that's okay, but trust me, other people in here had no idea what I was doing. Right. I know this from experience. Like pretending like everybody knew because I was being lazy. And it's like I knew in my head. People didn't know what I was doing. Okay.
It just says on the why do we find the y on the plot?
Oh, is that what the question says? Okay. Here's we're trying to find the integral of the current. And we're trying to find it as a function. So to find it as a function, I need to have these values as functions. I need to write my current as a set of functions. And so my current as a set of functions is 0 for t less than negative 4. It
It
is
is
50 t plus 100 for
for
negative
negative
4
4
less than t less than negative 2.
2.
It is
It is
100 for t between negative 2 and positive 2. It is negative 50 t plus 100 for t between 2 and 4. And it is 0 for t greater than 4.
So it's 200, it's not 100.
It is
It
200.
is 200.
Okay, and
Okay,
so I
and
think,
so I think
I'm hearing the question, why am I doing that? Because I have to take the integral. And
And
I'm not
I'm
taking
not
the
taking
integral,
the integral,
I'm getting the integral in terms of t. I'm not getting the integral like as an area under the curve, because that's a number. I'm supposed to be getting a function. And so in order to take the integral of something, I need to know what it is I'm taking the integral of. And so I just found out what the equations were for these lines.
If we just graph it and didn't find the equation, could we just use the area under the graph?
No,
No,
Okay.
because it's not a number. It's a parabola. The integral of a line is a parabola. You're probably not going to have this one, so I can just skip it. It's just like this is the sort of thing that I mean is the sort of thing you are supposed to know. I mean, you will when you take signals and systems. This is for those of you who are taking signals and systems. You have to be able to do stuff.
I need someone who has forward and it's not the problem.
What's the question?
How some in your electron flow chart
Mhm,
says bread. Is it breaded?
Bread is breadth.
breadth.
It's breadth.
It sounds so.
It does sound.
Sounds like
Okay.
Okay,
I have to admit I'm very discouraged. And apparently last time I did this review, I looked at this and said they won't like me, and I did a different problem. But it is what it is.
It is what it is.
It is what it is. I am going to stop doing it, however, because I'm tired of it. It's a lot of calculations, but the basic idea is still important, and I'm going to replace it with one that is much easier, but is the same concept. Okay, let's try this one. All right. The graph of the current across a 0.2 millifarad capacitor is given. Graph the voltage. Okay, so we know that the voltage is 1 over the voltage at the beginning plus 1 over c times the integral of the voltage from the starting time to the ending time. So in order to do this, we have to know what our current function is. It is 0 for t less than 1. It is 2 for t greater than 1. So the voltage is 1 over c integral from what is the voltage going to be from 0 to 1? I mean from negative infinity to 1. It'll just be 0. So for t less than 1 it'll be 0. It's not charged when we start. So from 1 to infinity, it'll be the integral from 1 to t of 2 dt. What's the integral of 2 dt? It's 2t. From 1 to t. So this is 5,000 times 2t minus 2, or 10,000 t minus 10,000. So if I wanted to graph that, I would get 0 until I got to 1. And then once I got to 1, this is a very bad capacitor because it's changing voltage instantaneously. It should not. No, it's not.
No, it's not.
At 1, it's 0. So at 1, it's 0. And then after that, it has a slope of 10,000. So it goes up like that.
Just a very fast.
Yeah. Charges a lot.
To
the voltage. So what you're hoping is that it's not an integral one, and we come here and we have an inductor, and we find out that the voltage across an inductor is L d I dt. And you say, oh, that's much nicer. We like those. So we go back and we say V equals L d I dt. So this we can just read off the graph. It is just the slope. Is the derivative. And so let's figure out what the slope is for our different intervals. So we have t less than negative 4. What's our slope? What is d I dt? For 0. And from negative 4 to 2, what's the slope? Yeah, it looks like it's negative 1.5. And from negative 2 to 2, 0. And from 2 to 4, 1.5. And greater than 4. 0. Okay. So now let's multiply those all by L. L is 0.1 millihenries. So we're multiplying by 10 to the negative 4. So this would be negative 1.5 times 10 to the negative 4. 0, 1.5 times 10 to the negative 4, and 0, and 0. All right. So then I will say I'll make these negative 15 times 10. Oh no, I'd have to go down by 2. I'll just do it in units of 10 to the negative 4. Okay, so up until negative 4, it's 0. So up until negative 4 it's 0. And then from negative 4 to negative 2, it's negative 1.5 times 10 to the negative 4. And then from negative 2 to 2, it's 0. And then from 2 to 4, it's 1.5 times 10 to the negative 4. And that's our answer. What is the energy stored in the inductor at time t equals 3 seconds? Well, what's the formula for the energy in an inductor? So the energy is 1/2 Li squared. And it's asking for the energy at time t equals 3 seconds. So that would be 1/2. L we know is 0.1 milli, so that's 0.0001. What is I at 3 seconds? It's 1.5 because it's right here. So it's right in the middle. So it's right here at 1.5. So 1.5 squared. So 0.5 times 0.0001 times, is that 2.25? And I get 0.001125 or 0.1125 millijoules.
So how does it go from 1.55 to 1.5 minus 4?
Because I multiplied by L, which was 0.1 milli. Because did I put the wrong thing in? Oh, okay. It makes sense now? Okay. Any other questions?